Hello wonderful person, this is Anton and you're looking at our beautiful planet Earth in a climate simulation in Universe Sandbox Square. In today's video we're going to be using a few tools to try to investigate if the climate change is a real thing or if it's something that media has created using Python, science, math, and a little bit of common sense. Anyway, welcome to What the Math. Now, in some of the previous videos, we talked about the climate change, we talked about the greenhouse gases and the global warming, and also tried to manipulate the values of carbon dioxide here and see how it actually affects the planet Earth. But today we're actually going to be doing something not as interactive, but something a little bit more realistic and basically something that will actually teach you a little bit of programming. I'm going to try to go a little bit slower here in case you've never done any coding or programming before, but I'll explain to you everything as I go. And if you actually want to follow along and try this yourself and try to recreate the data and results that I'm going to be getting in this video, go get Anaconda. Anaconda is actually a very interesting, absolutely free distribution of Python, which is a language I'll be using in this video, which is basically something that people use in science, something that people use in finances. It's a super useful tool that allows you to code on the go and to use Python very effectively. Anyway, you don't have to get this one, but this is what I'll be using. And when I open up my Anaconda Navigator, I'm basically going to be clicking on this. I'm using Jupyter Notebook, which is essentially a browser-based Python compiler thingamajiggy that allows you to run the scripts on the go. So if I were to actually click on launch here, it would open a window that kind of looks like this. And here I can actually create a new script, Python script, or I can modify my previous scripts. I can also make folders and stuff like that. I've already tried a few apps here previously, but I'm going to be actually creating or starting this right here, which is known as the weather app. Now, I could have come up with a better title for it, but that's what we're going to be doing. And essentially here, if you've never done any Python before, your first command would always be printing hello world, and in Python it's super easy. But you know what, we're not going to do this, we're going to be doing something more advanced. What exactly are we doing? Well, we're going to try to analyze data ourselves so that we can actually see if climate change is a real deal or not. And in other words, we're going to ignore the media, we're going to ignore the politicians. We're actually going to go and find a website that allows us to get data directly and then analyze it ourselves. Now, originally, I was actually going to use this. This is from NOAA, but this is a government organization, so some people might actually not trust the data from here, as I've realized from many of the comments under my videos. So some people still don't trust the government. So instead, we're actually going to go with another website that I discovered very recently. And this is the website we'll be using. It's Colorado State University website that actually has quite a lot of climate information and a lot of weather information that they've been collecting for at least 100 years, even more than that. There's all of these stations around Colorado that they have. You can go to them here individually, and each of them displays maximum temperature, minimum temperature, precipitation, and snowfall. So this is actually an awesome tool, and because it's a university not funded by the government, it's sort of an independent observer in that sense. If you still don't trust universities, you may want to go and find some other independent weather station, like for example the one right here in Germany. This is the Hohenpeithenberg. Oh god, I cannot pronounce this. Meteorological observational station. That's basically one of the oldest in the world. They have like 225 years of history. They're isolated from a city, so they don't get any warming effects from the cities. And they provide data for free. I'm not going to be using this one because it's kind of more difficult to organize it, but I am going to be using the Colorado State University because their data is easily accessible and you can try it yourself right now. Now, of all of these stations, I went through quite a lot actually and found one that has a consistent data for at least 100-year period, and this is the one called Buena Vista 2S. It's somewhere right here on the map. I think it's near, is that Chaffee? I think it's called Chaffee. And the actual location is here. It's about 8,000 feet above ground, and it has data from 1905 up to 2017 today when I'm making this video. It also has precipitation data even earlier and snowfall even earlier. So the cool thing about this particular tool that Colorado State University has is that you can basically choose what you want to display. So I'm going to go for annual first because it's a little bit easier to organize. And we're going to start at, well, let's go with the January of 1905 until basically today or yesterday. We're only going to be looking at minimum temperature and maximum temperature. And we're going to click on get data and voila, here's your data. It shows you pretty much everything from 1905 up until 2017 right here. Now there's obviously ways to save this data with Python, but I'm just going to literally copy and put this in a notepad file and then save this as a text file on my D drive. So it's actually going to be saved as weather.txt on my D drive right here. So now that we have this, let's go into our script and write a few lines of code that will allow Python to basically open this data and start using it. And we can maybe take a look at some of the patterns here. Now, in order for us to actually read the file or open the file, we need to, or we can use a command called with open. This allows us to basically open this file on D drive called weather.txt, read it, and then look at it as what's known as data. And so now that it's been read as data, we're going to take this data, read each individual line from it using the command called readlines, and save it in a variable called readData. Now, here's what happens if I decide to print all of this out. If I actually print my read data, it will give you all of this information, but in this really, really funky format with /t's and /n's. Now in Python, /t and /n actually have representation. This is a new line and this is a tab, so tab key. So in other words, this tabbing is /t and this is /n. And that's because our file has those. Now we don't really want these things in there, but so we're going to ignore them. We're actually going to collect years, mintemp and maxtemp. I think it's mintemp. Oh no, either way, maxtemp and mintemp into separate lists. We're going to create a bunch of lists and save each of these into those lists. So first of all, let's actually create 3 empty lists. The first one is going to be called year, this one is going to be called minimum temperature, and this one is going to be called maximum temperature. Now there's actually a much easier way and much faster way of doing all of this, but I wanted to do it slower and in more detail just so that those of you who are new to Python can actually see how all of this is happening. So if you're a programmer and you already know how to do this easier, do post it in the comments below and we'll take a look at it in the future. But I think this is how I'm going to do it just to simplify things. So 3 lists. Each list will contain this value into year, this value into maxtemp, this value into mintemp. Now Python is very powerful at analyzing data and adding things to things. And so here we're going to be using what's known as a for loop. The way for loop works is as follows. And this is a typical way of writing the for loop. So for I in range, whatever, 5 in this case. So here, the way it works is this. This is the variable created for the loop itself. And we're looking at the range of 5 numbers. So basically for every variable in the range of 5 numbers, let's say we're going to print out this actual variable. And this will actually give us numbers from 0 to 4. In this case, it's because computer starts counting with 0, not with 1. So if I were to change this to 10, it would stop at 9 instead of stopping at 10. Now we're not doing the counting here. We're actually going through our data list. So here we're going to say for I in read data, which is coming from this variable right here, we're going to print out I, and look what happens. It prints out each of these individual lines of code in a very easy to read way. It's still not good enough. We actually want to save individual years into years, maxtemp into maxtemp, and mintemp into mintemp. I should probably actually change the order because they are in slightly different order. All right, so here we go. Oh, but before we do this, let me actually show you one more thing. So here I'm actually just going to stop this for a second by using the hashtag. In Python, there is a way to display a certain value from a certain data list or from a certain data string by putting it in square brackets. So here, if I were to type read data and put square bracket 0 in it, it will actually just give me the first value. If I put 1 here, it will give me the second value, and so on. So this is the notation we'll be using for the next line in the script here. And so this is how we're going to attach years to basically to this list. We're going to say append, which is a Python list command that attaches something to the end of the list. And what we're going to attach in here is the I value, but actually we're going to only look at the first 4 characters from this line. And so here, what I'm gonna do is essentially just say, okay, can you please say for me from the I part only the first 4 characters from 0 to 4, not including 4. And what this will do is it will automatically append all of those things into my year now. How do we check? Well, we just print out the year now at the end, and this will show you if it worked. And look at that. All our years now are basically collected into this list with a comma, separated by comma, and all of them are basically what are known as strings. We'll have to change this later on, but we're not going to do it yet. Let's do the same for maxtemp and mintemp. Except for maxtemp, we're going to change this to 5 until 9, and let's check if this worked as well. We're going to print out the maxtemp, and so here's our maxtemp list. And now we're going to do this one more time with mintemp. So just copy this, put this in here, change this to min, and finally change this to 10 to 14. And just to check if it worked, we're going to print out the minimal temperature. And here's the list of mintemp. So all 3 lists are now ready to be plotted and to be graphed. That's all it takes to basically create essentially our X and Y values for the graph that we're going to be doing right now. So that part is done. Now, how do we actually graph all of this stuff? Well, Python doesn't have a built-in function, but it does have a very cool library called matplotlib. And you can learn more about this library by going directly to its website. It has a lot of really powerful graphing functions and graphing abilities, and it's basically one of the most used libraries in Python because it allows you to visualize data, to basically import it into your Jupyter notebook and to make it work right now. We're going to go on top here and add 2 lines. We're going to import matplotlib.pyplot as plt. This will allow us to plot things. And we also are going to import another library called numpy. This is for numerical analysis that we're going to be using for analyzing the averages in a few seconds. So now that we have this library, let's use it because now we can use a command called plt. I'm going to first type plt.title and give my graph a name. This is temperature since 1905. We're then going to give our axes a label as well. So the X label, the bottom label, is going to be year, or I guess years, maybe capital Y. And the Y label, the vertical axis, is going to be degrees in Fahrenheit. You can obviously change this to Celsius with a very short function that converts all of these values to Celsius, and maybe I'll show it to you in one of the future videos. But for now, we're going to be dealing with Fahrenheit. And we're basically almost there. So now what we have to do is type plt.plot and put X value, which is year, in this case it's the years, and mintemp, which is the Y value, is coming from here. So this will basically graph the minimal temperature for us, minimal temperature graph. And so what we do now is type plt and let's show the graph. And here you go, look at that. Here's our beautiful, okay, not so beautiful, kind of ugly graph. This is basically because we have so many data points and it's trying to plot each of them. We can change this in a few seconds. Same thing here. But that's what the graph looks like. This is for mintemp, and change this to maxtemp to see the maxtemp. And here's what the maxtemp looks like. And if you want to see both of them on the same plot, just add another line right here with basically both of them in the same graph. Now, the problem here is that because one of them shows the minimal temperature, which is winter, and one of them shows the summer temperature, which is, I guess, the hottest month, it will not actually co-align with each other. So it might be better to actually find the average of these, and we're going to do the average in a few seconds as well. But let's maybe make this a little bit more readable because it looks really ugly here. I'm going to start by typing plt.xticks, which will basically only deal with every tick on the x-axis. If it changes to y, it will be the y-axis. And then we're going to use that module we imported called numpy, which allows us to arrange items. So here, if I type np.arange, it will allow me to arrange all of my values from the x-axis in a certain way. And I'm going to type this. I'm going to say, I wanted to start with the year 1905, and I wanted to end at the maximum value from the list year. You can also just use min year here, but I wanted to show you how this can be different. And we're going to use increment of 10 years. So now if I run this again, you will realize you're getting an error, and you'll probably get a few errors along the way, but you have to read what it says. It says type error, unsupported type, string, and integer. And that's because if you remember here before, we added a year, but it actually added it as a string. We're going to change this to a float instead. This means a number that has decimal points. You can change it to integer if you want, but I think floats work a little bit better. And so now that we changed it to a float, we actually are going to change these two to a float as well. We're going to run this again and see what happens, and scroll down and look at that. We have this beautiful graph that has nicely displayed years and nicely displayed degrees in Fahrenheit. If this is not as good, you can change y-ticks and do the same thing for the y-ticks. So now we have our graphs. Graphs look pretty nice, but we don't really see any patterns yet. We see that there's like these two really cold years right here. I think this is like the 40s and the 70s. But overall, it doesn't really look like there's any trend. How do we check for trends? Well, first of all, let's create a new list, and this time it's going to be a list of average values. So we're going to create an average temperature. And this list will be populated from the values right here as well. So we're going to create average temperature appendage, and this will append the following. It will basically append, I know this is a little bit long, but basically here's what's happening. We're appending the minimum plus the maximum and dividing it by 2. It's that easy. It's the average of 2 years. So it will automatically populate this list and turn it into a float, which is exactly what we need. So now we can actually erase one of these plots. We don't need it anymore. We're going to change this one to temperature average and run this again to see if our average shows. And here's what it looks like. So you can already kind of see that maybe there's a bit of an uptrend going on here, especially like in the recent years. But it's so speculative, we don't really know until we plot what's known as the line of best fit, also known as a regression line. What the regression line shows us is an average trend of something towards something else. So in other words, if we were to look at all of these points individually and were to basically plot like the best line that would fit between all of the points, this would be what we would call a regression line or a line of best fit. This library known as matplotlib allows you to do this in a single line. It's that powerful. And so here's that line, this very, very powerful line that allows you to plot the regression lines. Here there's really only 2 entries. One of them is the year from our year list, and one of them is this numpy command called poly1d, which is basically a regression or a fit command. It takes these 2 values, year and average temperature, and at the end it also asks for year again. So if you basically plot this right now, you will automatically see your regression line. There it is. Now let's remove the other graph for a second. So let's actually remove this by putting a hashtag and look at that. Temperature since 1905 has increased by what seems to be 4 degrees Fahrenheit. Now, this is pretty intense. This is actually a lot more than I expected. And I only used one of the data from a climate center right here in Buena Vista, but you can actually try this again with several other ones just to see if the pattern repeats. There's actually quite a lot of them. There's a lot of different choices, and some of them even have data from even before. So here's one called Cheyenne Wells, which basically shows you data from 1897. You can also do this by month, and I actually encourage you to try this by month. So choose monthly, and you'll get a lot more data points. Some of them will be missing, unfortunately, so you may have to remove them, but try this yourself and see if you get the same results, and then post in the comments below if you have any other ideas of how you could maybe improve this script, or even better, if you have any other ideas of how and what we should analyze using Python, because this essentially allows you to analyze data yourself, and instead of listening to media, you can just go there and explore it by yourself and come to a conclusion based on what you see. Now, to me, this is a pretty obvious trend. 4 degrees in the last 110 years, that's pretty intense. In Celsius, it's obviously a little bit less, but in Fahrenheit, it shows you quite a dramatic change. This is only from one of the data centers, and I do encourage you to try it with the other ones. So here's the script. If you would like a copy of this, I'm posting this in the description below, and you can definitely explore more various data analysis using Python and using Jupyter Notebook, and most importantly using matplotlib, which allows you to plot things very, very easily. So in conclusion, all in all, it seems that the data science shows us that there is definitely an uptrend of temperature. What it's based on and what causes it is another question, but it's undeniable, and you can't just say that it doesn't exist. If you still think that for some reason climate change is created by the media or created by the government, well, take a look at some other data from other places that are independent of the governments. There is quite a lot of places in, for example, Australia that keeps track of weather reports and weather data, and they've been doing it for hundreds of years as well, or for at least 100 years. And there's also a lot of other ones in European countries, specifically in Germany. Quite a lot of them are located there as well. Check it out. If you have any more suggestions or more cool data sources you've discovered, please post them in the comments below so I can take a look at them as well. Thank you for watching, guys. Hopefully you learned something from this. And so now, hopefully you know a little bit more about Python, a little bit more about data science and how to analyze data, and most importantly, you now understand where this whole climate change argument comes from. Let's destroy our Earth, just because why not? And come back tomorrow to learn something else. Space out, and as always, bye-bye.